Welcome students in this topic, application of a junction diode as a rectifier. This topic is taken from the chapter Semiconductor Devices from the class 12 physics, which is important for CBSE, NEET as well as for the IIT JEE examination. Let's begin the topic with the first question, that what is rectifier, student? So rectifier is a device that convert alternating current into direct current. The conversion of AC into DC is called as rectification. There are various type of rectifiers. Here we are going to discuss half wave and full wave. So the first one is half wave rectifier. So the first topic is half wave rectifier. In a half wave rectifier, students, as you can see the circuit, there are a number of primary turns and secondary turns. The primary turns and secondary number of turns is based on the like a transformer, but here is a one half diode. One diode is a basically PN junction diode, which is connected like that. Now, if we just start to signal, giving the signal input, in which the I naught current is flowing through it, we get this kind of signals in the output. So this is called a step down transformer. What happened actually? The circuit diagram for the junction diode as for the half wave rectifier is shown as figure. It consists of diode D connected in the series combination. Student, this point is important. This connected in the series combination with the load resistance RL. RL you can apply as a bulb, any high resistance appliances, so that we can say that this current is actually conducting. Across the secondary winding for a step down transformer. Primary of the transformer is connected to the AC supply. How it is started to working? Let us see. During the positive half cycle of input AC, and A of the secondary winding becomes positive and end B is a negative. This diode D becomes forward bias and conduct the current through it. So current in the circuit flows from A to B through load resistor RL, as you can see here. During this negative half cycle of the input AC, and A of the secondary winding becomes negative and end B becomes positive. So diode D becomes reverse biased and does not conduct any current. And in the case of again, there is no current flows through the circuit, since current through the load resistors RL only, and flows during the positive half cycle in a one direction, that is from A to B. So DC current is or a direct current is obtained. Point which we have to memorize, important point, that input frequency must equals with the output frequency and maximum efficiency should be 40.6%. Next, ripple factor. So ripple factor R is equals to AC component by DC component. Which is the value comes I square I RMS square by I mean square minus 1. After solving, we get the value 1.21. I RMS is equals to I naught by 2 and I mean is equals to I naught by pi. From factor I RMS by I mean is equals to 1.57. In the case of full wave rectifier, students, for full wave rectifier, we use two type of a junction diode. The circuit diagram for full wave rectifier using two junction diode is like that. So a full wave rectifier consists of two diode connected. So when the load resistance RL is connected across the secondary winding, the diode between the A and B as shown it in the circuit. In the previous one, as you can see, there will be one single diode, but here is a two diode are present over here. During positive half cycle input, AC, and A is secondary winding becomes positive and B is negative as to diode D1 becomes forward bias, whereas the diode D2 reverse bias, so D1 allows the current to flow through it while diode D2 does not. And current in the circuit flows from D1 and it flows through load resistance R1 from X to Y. During negative half cycle of input AC and A of the secondary winding becomes a negative and B positive, thus diode D1 becomes reverse bias whereas diode D2 forward bias. So diode D1 does not allow the current to flow through it, but diode D2 does, and current in the circuit flows from D2 and through from load resistance RL from X and Y. So both the half cycle and input AC electrical current pass from the load resistance, which is the responsible case for the both directional flow of a current. So DC is obtained across RL through the direction of electric current through RL remains same, but its magnitude changes at the same time, so it's pulsating form of a DC. Some important points which we have remember that output frequency is 2 times of input frequency and maximum efficiency is again 81.2%. Ripple factor is R is equals to 0.48%. IRMS is equals to I naught by root 2 and I mean to I naught by pi. In this figure given below, this is a question actually. In this given figure below, input wave form is converted into the output waveform by device X. Name in the device circuit drawn. So device X is the full wave rectifier as you can see from the outside. Next, an AC circuit signal is fed into two circuit X and Y and corresponding output in two cases have waveform as shown. Identify the circuit X and Y. Draw their level circuit diagram. Briefly explain the working of Y and how does the output waveform from circuit Y get modified when a capacitor is connected across the output terminals parallel to the load resistor. So the X will be half wave rectifier and Y will be the full wave rectifier. See the theory. So a capacitor of a large capacitance is connected in a parallel to a load resistance RL. When the pulsating voltage supplied by rectifier is rising, the capacitor C gets charged. If there is no external load, the capacitor would have remains changed, or we can say charged to the peak voltage of the rectified output. However, when there is no load and rectified voltage start falling, the capacitor get discharged through the load and the voltage across capacitor begins to falling slowly. So this is all about for today's class, students. If there is any doubt, you can ask in the comment section. Till that, take care everyone and be connected with the Snuggie group. Thank you for watching this video.